we're going to look at some basic laws of how you solve equations using factoring. So hopefully by now you're super awesome, and if I give you something like this, you can go, oh, that's the same thing as this. Okay, if this is completely foreign to you, then nothing from now on in this particular video is going to make sense. So go back and figure that out, and then come back to it later. It's totally fine. You just need to be prepared. So solving by factoring is very important. And the basic strategy, I guess, that we use behind this is along this line. If I have two things multiply together, like x and y, if I know this equals 0, I want you to think about all the different things that x and y could be that would make this true. Okay? So you might say, okay, well, if x is 3, then y would be what to make it 0? So hopefully you'll say 0. If x is -1, what could y be to make this, again, equal to 0? Go, 0. Okay, you see where we're going with this? If I say x is 236.9, what do I need to multiply that by to get 0? Okay, there's really only one answer, 0. Okay, likewise, all right, what if I start changing values for y? What if I say y is 97? What do I need to multiply it by to get 0? 0, right? Same thing for -322.6. What do I need to multiply that by to get 0? Again, 0. Okay, so this is the basic idea behind solving things by factoring, is if you multiply two things together, we'll actually write this up. If you multiply any two things together to get 0, then one of those things has to be 0. Cool? Things has to actually be 0. Right? And this is sufficiently important that I wasted the last whatever seconds writing it out, because it's really, really important. If you multiply any two things together to get 0, then one of those things has to actually be 0. Okay? So let's go back to that example I had up there a second ago, which was x squared plus 5x plus 6. Now this doesn't work with addition, right? If I say that, say x plus 5 is, or x plus y is 0, does that mean either x or y has to be 0? Well, no, that would just be silly. Like, if x is 5, what is y? Yeah, that would be -5. Or if x is, and then obviously, if x is 92, then y would have to be -92. Okay, so it's really important to note, not for addition. It only works for multiplication and division, because division is kind of like basically the same thing as multiplication, just upside down. And divide, or divide, multiply or divide, we'll say it that way. Okay, so we can't do this for addition, so I can't say, well, this means either x squared is 0, or 5x is 0, or 6 is 0, that makes no sense. I have to make this to where, I have to turn this into multiplication. Multiplication, yeah, here we go. So I have to turn this into multiplication. Okay, so really what I'm going to need to do is I'd like to have this to where I have something times something is equal to 0. So again, we've already established what this is. This is x plus 3 and x plus 2. Now, the only way that this can be true is that either x plus 3 has to equal 0 or x plus 2 has to equal 0. The only way that this can be 0 is if this is 0, is if one of those is 0. Okay, so that's where we're going with this. So now I have two different equations which I have to solve for x. So we get x equals -3, or if I subtract 2 from both sides over here, x is equal to -2. Sometimes you'll see us write it like that. something like that. But that's the idea. So this is your basic strategy. I'm trying to fit everything not on one page, but so you could kind of see it all at once. So whenever you're solving by factoring, again, you want to use the idea that if you multiply two things together and you get 0, one of them has to be 0. So if you end up with some kind of an equation, what you want to do is you want to take, so you have this equation, then you want to factor it, and then you want to set each separate item to 0, solve for that item, and then you get the different values that x could be. And for the moment, it's just as straightforward as that. We can obviously complicate it, and we'll do that eventually, but this is just to kind of get you started. Okay, so let's look at some more examples. Let's just say you start off with something that's really direct. Say they've already factored it for you. Say you have x plus 4 times x minus 5 equals 0. And they say solve for x. Okay. Now what you can do is you can go in here and you can say, okay, well this means that either, and I'm just writing either for the moment so we're really, really clear, because they can't both be at the same time. Either x equals 4, either x plus 4 equals 0, or x minus 5 equals 0. Okay, so if I solve for x on each one of these, I'll get that x is equal to negative 4, or x is equal to 5. Pretty straightforward, right? I mean, you can't get a lot, quote, I don't know if easy is the right word to say, but you can't get any better than this insofar as a factoring problem, because it's just right there for you. Okay, so that's the basic strategy. And it works for everything. If they give you something like this, x times 5x minus 2 is equal to 0. Okay, again, you can come in here and you can say, okay, well, given these options, I'm multiplying this thing times this thing. So the exact same strategy applies. Either x is equal to 0, or 5x minus 2 is equal to 0. Okay, so you just write it out. It's that straightforward. So to solve here, add 2 to both sides. This takes a little bit more work to do. So x equals 2/5. So my options for x is either 0 or 2/5. Like that. Got it? Okay. Every once in a while they can try to throw a curveball at you. They could say something like this. Well, let's do this one first. Okay. So looking at this, it's this times this. So either 3x equals 0 or x plus 7 equals 0. So over here on the left you can solve for x by dividing both sides by 3. Over here by subtracting both sides by 7. So x is equal to 0 or x is equal to negative 7. Okay. Now, I just did it this way because it makes the most sense. Well, to me, there's another way, or another thing that can come up. What if instead of 3x, it said 3 times x plus 7? Okay? This might seem a little weird, because in fact, what you could say is you could say, okay, so that means either 3 equals 0 or x plus 7 equals 0. And that's okay. Wait, try this again. 3 equals 0 or x plus 7 equals 0. And you go, wait, that's just silly because 3 can't equal 0. And you're absolutely right. We disregard this because it's a completely silly answer. And then we just solve this to get x equals negative 7. And that's okay. Let me prove to you why this is okay to do. Now, if I have 3 times x plus 7 is equal to 0, if I didn't know how to factor, I could go ahead and distribute that 3 across, right? So I have 3x plus 21 equals 0. And I can solve this like a regular algebra problem, right? So I can come in here, minus 21. So 3x equals negative 21. Divide both sides by 3, and get x equals negative 7. So you see here, I get the same answer both ways, But one might say that this is easier because it takes less steps. So that's another option going forward. Less steps doing it this way, and it's all well and good. Okay, so that's kind of, if you see something like that with a number out front, we could technically say, well, that means 3 equals 0, or that's an option, right? Because we have that little word up here. Either one of these is true or the other. Well, that one clearly isn't true, so we can just throw it away and pretend it never happened. And that's okay. Okay? Now, where you're going to see most of your factoring, or most of your solve by factoring problems, are going to look more complicated. So something like this. Okay? So this is where it's really important to be able to factor, because if you can't factor right, then there's really nowhere to go in this problem. Okay, so I'm going to look in here, x and x. The two ways I can get this are 22 and 1, or 11 and 2. This is a minus, so that means our signs are a plus and a minus. And if I mess around with it a little bit, I'm going to get negative 11 plus 2. That'll give me minus 11x plus 2x gives me negative 9x. That's good. Okay. Move that out of the way. Okay, so I have this times this is 0. So that means that either x plus 2 is equal to 0 or x minus 11 is equal to 0. And I can go through here and get something like that. So x is negative 2 or 11. Got it? All right. And really, that's how it goes from here on out. Let's see, what else do I want to mention? Here's an interesting one. Say I had this. Okay. Okay. Now, looking at this, I could maybe originally come up with the idea that I can factor out a 3x. If I do, I'll have an x squared here, and the second term I'll have a 4? 4, yeah. Okay, now it's important that you keep factoring until you're totally done factoring, and the next important thing to do in this problem is to recognize that this factors. It factors because it's a difference of two squares. So that there is going to factor into this. All right, so hopefully you've done this enough that you can get here. All right, now you can say 3x is going to equal 0, or x plus 2 is going to equal 0, or x minus 2 is going to equal 0. So I can solve all these. Didn't quite look the way I wanted it to. Like that. So either x is 0, or x is negative 2, or x is positive 2. So x is negative 2, 0, or positive 2. Okay, now this is all well and good, but let me give you a bad way to do this problem. A bad way. I don't know what that says. A bad way. All right. What if instead of giving you 3x cubed minus 12x plus equals 0, what if instead you got this problem? Okay, can we agree that these are the same thing? Same problem? Yeah, right? Same problem. All right. Say you were given this problem. Now, if you're maybe not thinking, or are thinking and just have never been told this, a very, very natural thing would say, I'm going to divide both sides by 3, which actually is fine. But then you might say, well, what if I divide both sides by x, because they both have an x in common, okay? And then I'll get, x squared equals 4. So then I can move the 4 over, and then I can factor it to x plus 2, x minus 2, and so I've got x equals negative 2, or x equals positive 2, so my answers are 2 and negative 2. Now, what happened between here? See, I should be getting the same answer, because I solved the same problem, right? I lost the 0. That's bad. just in case. Now, here's the mistake that I made. This is the mistake I made. Never, ever, 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 yeah, you get this? Never, ever, ever, ever divide by a variable. It's a really bad idea, especially when you're getting started in algebra and don't know what you're doing. It's kind of like, how should I say this? Like driving a standard, like you can do it. It's just really hard. You got to know what you're doing. You can divide by a variable. You just really, really, really have to know what you're doing. And at this stage, you're probably not ready for all the rules and stuff about when it's okay and how to handle it and blah, blah, blah. So for the moment, until somebody tells you otherwise, never divide by a variable. The problem might already have a variable in the bottom of an equation, and we'll get to that pretty soon. But until you have to deal with this, do not do this because you will lose answers, okay? So if you're working problems and you're not getting the right answers, and you're like, what's going on? Make sure that you're not losing something entirely, okay? So never, ever, ever divide by a variable until you know better, I guess we should say. So there. Just make sure that you don't do this. So again, I just want to make sure that I got this across. I solved the exact same problem. This is the exact same problem, but whenever I solved it correctly, I got 3 answers. When I solved it badly, I got 2 answers. Now about the only thing else, I'm actually going to go do another couple videos, or 1 or 2 at least, where I'm just going to work a ton of these. But the last thing that you need to be concerned about is occasionally you'll get a problem where I'll say something like, you know, write an equation whose solutions are x equals, say, 3 and x equals 2. And this really isn't hard at all. Basically, they just want you to work backwards. I can't spell apparently at all. Work backwards. So instead of, you know, working the problem this way, they want you to work the problem this way. So if I start out with x equals 3 and x equals 2, I would get x minus 3 equals 0 and x minus 2 equals 0. So I'm going to multiply them together to get x minus 3 times x minus 2 is equal to 0. And then if I FOIL it, I get x cubed minus 3x outer, inner, actually did it inner, outer, last. Okay, so we actually have already done, well, no, we didn't quite do this problem. We did a similar problem. But basically, instead of starting here and factoring this way on this problem, I started here and went down. So that's about the only other thing they could do that's really kind of silly with this problem. But I'm just going to give you a ton of other examples here in an upcoming video.